Hello everyone. We are going to talk today a little bit about how some of the numbers that we want to get into our kids or our heads early work together to form other numbers. So remember, we've talked about E, I, pi, minus 1, 0, square root of 2, square root of 3, square root of 5, not so important, phi, a number called a vector, 1, 2, 3, with a chaser, a number called the identity matrix, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there's two more that obviously I can't remember. All right, so we know by rote, hopefully, very quickly, it's a poem. E to the I pi equals minus 1. Or maybe, depending on where the kids are at, you can just write it out, E to the I pi plus 1 equals 0. This, of course, is Euler's formula. Evaluated at x equals pi. Because Euler's formula really is e to the I x, which is the same as cosine of x plus I times the sine of x. But let's not worry about that. Let's first learn how we can use these numbers to form the numbers within. For instance, a rule of any number to the 0 power, except for 0 of course, equaling 1 looks like this. 2 to the 0 power equals 1. 3 to the 0 power equals 1. 4 to the 0 power equals 1. Minus 2 to the 0 power equals 1. Minus 3 to the 0 power equals 1. Minus 4 to the 0 power, and you probably should get in the habit of doing this if you're on a computer, equals 1. And so it should follow along that e to the 0 power equals 1, and I to the 0 power equals 1, and pi to the 0 power equals 1. Or, realistically, the square root of 2 to the 0 power equals 1. Or, the square root of 5 to the 0 power equals 1, etc., etc. Recognition and understanding of this in rote will help later as we try to do things like converting 1 to 1. Or converting 1 to 1. The concept that very often it will help our brains, especially this one here, when we start talking about growth, to think that anything to the 0 power is equal to 1. So then it finally comes down to perhaps proving to kids that this is true by coming at things from the right and from the left, And the things we're going to start at is, you know that this is 1, or that's what you're heading for. If anything is going to be, the answer is going to be 1. You then have perhaps 10, 100, 1,000. 10 to the 0 we think is here. But we can go back here and start at 10 to the 3rd. How do you go from 10 to the 3rd to 10 to the 2nd? You divide by 10. You get 10 to the 2nd. You divide again by 10, you get 10 to the 1st. You divide again, you get 10 to the 0. You divide again, you get 0.1, and you have 10 to the minus 1, which is the same as 1/10. Divide by 10 again, you have 0.01, which is 10 to the minus 2, which is 1 over 100. So getting students to kind of play around with the visual pattern of how you actually get to the fact that anything to the 0 power, except for 0, is 1, will help later when in fact you want to start playing around with concepts like using this to be the number 1 and then growing the number 1 by multiplying by some growth factor. Let's see what that looks like. And I have to put a shout out to www.betterexplained, where you should go, depending on who you are, to take a look at the discussion of the analogy between the circle and growth. So, that said, let's look at e to the 0, which of course is equal to 1. And if in fact we want to apply a transformation or growth to it, we want to apply something to it, and usually we're going to try to get our transformations here. But in this case, for imaginary numbers, we're going to try to put our transformations here. All right, so we're going to transform that by growing it 100%. And we do that by multiplying by e to the first power for 100%. Now 100% growth, natural growth, does not equal 1. It does not equal 2, basically. It equals 2.713, etc. Because you remember that e is 1 plus a very small number to an infinite power, and that becomes 2.73, or e. So in this case, if we're going to grow 1 by doubling growth, we get, by rule of exponents, just e to the first power, not e to the I power. If we're going to grow 1 by twice doubling growth, or doubling growth for 2 years or 2 periods, we're going to get e to the second power. What I want to point out here is that implied, very often you won't see this, because if you remember, that's just 1. That's just 1. Very often in math you just ignore the 1, but it will help to say that you are starting with 1 and you're going to perhaps not grow, but shrink. To have negative growth. And this, of course, equals 1 over e. So you start with 1 and you end up going down to 1 over e, which of course is 1 over 2.73, which of course is 1 over 1 plus a very small number, 1 over infinity, to an infinite power. If you think about growing and shrinking in this way, you will realize you will never get to negative numbers until you'll never get to 0. You will never get there. If you grow and shrink, right, not in terms of profit and loss, you can't have, I don't know, negative amoeba. But when in fact you do that, you will be then dealing with imaginary numbers, things that you necessarily can't get out your brain across or around. All right, so let's think about this. That's the number 1. That's the number 1. Even that's the number 1. 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 The only thing that's not the number 1 is that. And what does this mean? One. 1, 1, 1, 1, 1. 1 is 1. And of course it is part of our series of numbers that we like to use and get attached to, be befuddled by early. E, I, pi. 1, 0, minus 1, square root of 2, square root of 3, square root of 5. Phi, a vector, a matrix, the identity matrix. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And of course there still is one more, infinity, which of course is pretty close to 1 over 0. And so the final series of numbers that we're going to play with and use and get to the point where the formal math of 2 plus 2 is covered, yes. But the formal math of e plus e equaling 2e does not throw us. Or 2 times 2 is fine, but so is e times e. 2 times 2 is 2 squared, and this is e squared. E squared divided by 2 squared divided by 2 squared equals 1. E squared divided by e squared equals 1. So another way to think about the 0 power is also dividing anything by itself will get you to the 0 power by the exponent rule. Thanks for listening.